Let's take a look at our skills for predicting the distances to images and the heights of images. We do this using our new mathematical tools, the thin lens equation and the magnification equation. So in this situation, we've placed Spider-Man in front of a lens. The lens has a focal length of 17 centimeters, and Spider-Man is located 42 centimeters from the lens. The height of Spider-Man is 8.5 centimeters. We're not going to do the ray diagram here. If you need help with ray diagrams, go check out the video for those. We'll focus on the mathematical work. So here we go. So our job is to predict the distance and the height of Spider-Man's image. So we'll begin with the distance. In order to find that, we're going to use the thin lens equation. So whenever we do our math work in science, we are always very careful with our process. We begin by describing the purpose of this work. So the first bit of work is going to find the distance. So our next step is to write the equation, and that always means to write the complete equation. So this is our thin lens equation. 1 over the focal length is equal to 1 over the distance to the image plus 1 over the distance to the object. We want to isolate the unknown. So our goal is to find the distance to the image. In order to isolate that, we have to move this term to the other side of the equation. When we do that, this term becomes negative. So therefore, on one side of the equation, we're left with this, 1 over the distance to the image, and that's equal to, on the other side of the equation, we started with this, 1 over the focal length, and when this is brought to the other side, it becomes negative, minus 1 over the distance to the object. Another way of thinking about this math work is we subtracted 1 over dO from both sides of the equation. Now we have isolated our unknown quantity. We're ready to substitute values with units, so don't forget those units. In this case, the focal length was 17 centimeters. And then we subtract 1 over the distance to the object, which is 42 centimeters. It's time to do a calculation. When we do our calculator work, it's really helpful to use the reciprocal function on the calculator. On this calculator, it's this symbol here, x to the power of negative 1. So I use that by doing second function and then this bracket button. So I'm going to put into the calculator 17 reciprocal minus 42 reciprocal. And then I don't have to worry about punching in the 1 divided by this, 1 divided by that. So 17 reciprocal minus 42 reciprocal. And this result will give us a decimal number. It's a small number, so we want to make sure that we include 4 decimal places so that we have enough useful digits. Now it's important to remember that this result is 1 over the distance to the image. This isn't our answer yet. In order to find the distance to the image, we have to take the reciprocal of this side and the reciprocal of this side of the equation. Remember, that's the basic principle of doing our math work. When we're working with equations, we always have to do the same operation on both sides. In this case, it's a reciprocal operation. Therefore, the distance to the image is, now I'll take the reciprocal of this. It's already in the calculator, so all I have to do is use the reciprocal function one more time. And there we go. So this is in units of centimeters, so I'm going to round it to the nearest millimeter, 1/10 of a centimeter. So we've found the distance to the image. Our next task is to find the height of Spider-Man's image. So we follow the same process as before. Let's describe the purpose of this work. So we want to find the height of the image. So now we know the distance to the image, the distance to the object, and the height of the object. So we're going to use the version of the equation that looks like this. Hi over ho is equal to negative di over dou. So our goal here is to find the height of the image. And so the next step after writing the complete equation is to isolate the unknown. So to isolate this, right now it's divided by the height of the object. So we have to multiply both sides of the equation by the height of the object. When we do that, on this side, the height of the object divides away. We're just left with the height of the image. On this side of the equation, we multiplied by the height of the object. So this is what we had before, negative di over dou. Now we've multiplied by the height of the object. So this is our isolated equation. Now we're ready to substitute with units. So the distance to the image we found was 28.6. Whenever we substitute here, it's always helpful to put the substituted quantity in brackets. The height of the object we were told was 8.5 centimeters. And this is all divided by the distance to the object. That was 42 centimeters. Now we can calculate. First with the units, those units will divide out with those units to 1. We're left with units of centimeters. And now we'll put the results in our calculator. And I get this value here. We'll round it off. So this is in units of centimeters. We'll round it off to the nearest millimeter. And we know that this result is negative from the negative sign in the equation. So let's state our conclusions. This is the final step of our work. So the image is located 28.6 centimeters from the lens, and its height is negative 5.8 centimeters. Now we'll be learning soon that what this negative sign means is that the image is inverted. So if a height is negative, it tells us that the image is inverted. And so that will be helpful when we describe the characteristics. So the size is smaller than the original, 8.5 centimeters versus 5.8. The attitude, so that negative sign here, was telling us mathematically that it's inverted. And we also had the ray diagram to help us out, so we knew that it would be inverted. The location is on the opposite side of the lens. We see that from our ray diagram. And the type is real.